Okay, so we are going to use the definition of the derivative to take the derivative of this function. So, reminder, what is the definition of the derivative? The definition of the derivative is, whoa, don't need to do that in fingerprint. Okay, so what do we got? Finger paints. So we have the derivative of this function, or of a function, equals the limit as delta x approaches 0 of f of x evaluated at x plus delta x minus f of x all over delta x. Okay, so that's our definition. Let's apply it to this function. So let's see what we got here. So I'm going to say the derivative of our function. So now I'm just going to start plugging in some specific things here. The limit as delta x approaches 0. So I really want to emphasize what's going on here for those people who struggle on this. The first thing I'm going to do is I'm going to take this x plus delta x. I'm going to put this in. I'm going to make it red. And wherever I have x, right, here and here, wherever I have x, I'm going to substitute in this red stuff. So let's do that. So the first thing is x squared, right? But I'm going to be plugging in that, I'm just going to, again, highlight it. I'm going to be plugging in that x plus delta x, right? Again, wherever I have x, I'm replacing it with this. Okay, so then we say minus 2x, so minus 2 times x, and again, x in this case is x plus delta x, and then plus 3. Since there's no x there, there's nothing to substitute in. Okay? Now, so I have taken care of, just to be clear, I have taken care of this part so far. Now I have to subtract f of x. What is f of x? That entire function. Be careful. Make sure this is in parentheses, right? We want to make sure we're subtracting the entire function and not just the very first term of that function. And then finally, that's all over delta x, okay? That is a really important key part, okay? A really important key part. From here on out, we are just going to do a lot of algebra. So that was that was a step of calculus. Like I said, from here, we're doing a lot of algebra. So let's do our bunch of algebra here. So I'm going to take the limit as delta x approaches 0, and I'm going to expand this out. So let's see, that first term becomes x squared plus 2x delta x plus delta x squared. Okay, that takes care of that first term. Now I'm going to move on to the second term. So distributing, I get negative 2x minus 2 delta x. Here's hoping I have enough room. Okay, so I've done that one, and then I'll go to plus 3. Next, I'm going to remove the negative here. So I'm just going to distribute that negative. So I get negative x squared plus 2x minus 3 all over delta x. Okay, now it's time to see what crosses out. I'm going to cross everything off using, using the color red. So let's see, I have an x squared here and a negative x squared here. I have a negative 2x here and a positive 2x here. I have a positive 3 here and a negative 3 there. Is there anything else? I don't see it if there is. So let's do a rewrite on this now. So what do we get? We get the limit as delta x approaches 0 of 2x delta x plus delta x squared minus 2 delta x. Looks good to me. Let's keep on going. All over delta x. Okay, let's factor out a delta x from both top and bottom. So we get the limit as delta x approaches 0. And again, I'm factoring out something from top and bottom. So I'm going to get that 2x. The delta x in the first term cancels out. This one, I just get a delta x and then a minus 2. So look at that. We did, what is that? We did like 3 or 4 steps of of algebra. Now it's time again to finally do some calculus. This is easy peasy. I'm going to be substituting in delta 0 for delta x. So I get 2x plus 0 minus 2. So my derivative in the end is going to be f prime of x equals 2x minus 2. And let's see if that makes sense. So our original function, right, we can check this. That's what's so great now. So our original function was x squared minus 2x plus 3, right? So the original function was, actually, let me do this I'm going to do this in a different color because I'm just checking this. I just want to make sure I'm right? So the original function was f of x equals, what do we say? X squared minus 2x plus 3. So x squared minus 2x plus 3. And using the power rule, right, I get f prime of x equals 2x minus 2. Yep, they're the same thing. So I definitely did it right. So again, the nice thing is we now also, not only do we have a quicker way of doing things, but we have a nice way of checking our hard work here. Okay, let's move on. I'm going to do one more here of these definitions ones. Okay, so again, you know what I'm going to do? I'm going to go and grab that definition. For me, it's nice to have. It's nice to kind of think, you know, to have this little model right here or this equation right here. Just makes the thought process a little bit easier. Ooh, let's paste that right there. So there's our definition again. Let's use it again. So what do we get? So substituting this specific equation in, we get f of x equals the limit as delta x approaches 0. So again, I'm going to be plugging x plus delta x into my function. So again, I'm evaluating this at x plus delta x. So I get x plus delta x plus 1. Again, note, this right here has gone in for x. That's how I got this. Minus f of x. Well, f of x is the function. Perfect. All over delta x. Okay, as you can probably guess, time to do some algebra. So in this case, I think you'd agree, there's nothing I can do in terms of just removing radicals. So what we've done before, right, and I'm going to do now, is I'm going to multiply both top and bottom by the conjugate of the numerator to get rid of those radicals. So I'm going to get x plus delta x plus 1 plus, right, that all over, and of course, since it's 1, it's all over the same stuff. So x plus delta x plus 1 plus x plus 1. Okay, so let's see what we get. Going back to blue. I get the square, well, actually, let me write my stuff. It's down here so I don't get lost. Easy to get lost, right? Okay, so we get the square of the first, which is x plus delta x plus 1, minus the square of the second. Again, parentheses are important, right? I want to make sure that it's minus that second whole term, not just, you know, so if I didn't have parentheses there, really easy to make a mistake. And then in the bottom, what do we get? We get delta x times the square root of x plus delta x plus 1. I'm going to extend that square root plus square root of x plus 1. Right? Okay. Time to do some algebra. Let's see if we have anything that cancels out in that numerator. So let's see here. Actually, no, you know what? Before I do that, let's simplify. I have some parentheses. Let's get rid of those parentheses. By the way, notice that you can take things slowly. There is no advantage to doing a lot of stuff in your head, so don't. You're just bound to make mistakes when you do things in your head. So notice, could I do this in my head? Probably. But might I make a mistake? Yeah, I might. So why do that? So let's see, I get x plus delta x plus 1 minus that stuff. Okay, so now let's go and cancel some stuff out. So what do we got? We got this plus 1 and this, whoops, I want to do that in red. So I got this plus 1 and this minus 1, they cancel out. I got this x and negative x. So the only thing it looks like I have in the numerator is that delta x. That's kind of fantastic. So what do we get? We get the limit as delta x approaches 0. And again, in the numerator, all I have is that delta x In the denominator, I have all that stuff. I'll make that a little longer this time. See if I can make this look a little bit neater. Okay, so from here, notice now I can cancel out a delta x on top and bottom, except I want to do that in red. So bam, bam, goodbye delta x's. So where are we? What is our similar function? Our similar function is the limit as delta x approaches 0 of 1 over that denominator, and I am going to cheat and copy and paste because I can. So we got copy, paste, bam. Okay, again, look at that. All these steps of calculus, right? I mean, all these steps of algebra. So algebra, 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 algebra. Now, oh, some calculus. Fantastic. So now I'm going to be substituting in that delta x. So I get 1 over, let's see, substituting in 0. So we get x plus 0 plus 1 minus x plus 1. So in the end, right, we get f prime, right, our derivative equals 1 over, and we have 2 x plus 1s. So 2 root x plus 1s. And again, we might say, well, did we get it right? Well, we have a really easy way of checking, right? So our original function was, and I will do this in purple, our original function was f of x equals the square root of x plus 1. Let me just double check that. I'm pretty sure that's correct, but I don't, yep. So let's see, doing a little bit algebra, I get this to the 1/2, whoop, taking the derivative of this. Nice thing is I can even do chain rule here. So I get 1/2 times x plus 1 raised to the negative 1/2 times the derivative of x, which is just 1. I'll put it here just for looks. How about that? So this simplifies. I'm going to simplify this in this case. This becomes 1 over 2 x plus 1. And hey, look at that. They're the same. Fantastic.